You are dangling 80 feet above a canyon floor on a rope of wild vines. Bare hands, sticky with liquid gold, hundreds of furious bees swarm your face, stinging your neck and forehead. You are bleeding and trembling with exhaustion, yet you refuse to fall. You shove a chunk of raw honeycomb into your mouth. An explosive burst of pure sweetness hits your tongue, and your brain floods with dopamine. You risked your life for 2 ounces of sugar, not out of greed, but because an ancient biological command buried deep in your DNA forced you to do so. Modern dietitians, wellness influencers, and doctors constantly tell us that our intense addiction to sugary foods is a failure of personal discipline, a moral weakness, or a defect of the modern mind. We feel an overwhelming sense of guilt whenever we reach for a second slice of cake, a cold sweet soda, or a handful of candy late at night. We blame aggressive supermarket marketing, multinational food corporations, and our own lack of daily willpower. But evolutionary biology and paleontology reveal a far stranger, far more startling truth. Your uncontrollable craving for sugar is not a modern mistake. It is an ancient, hardwired biological survival mechanism that saved your ape ancestors from complete biological extinction during one of the coldest, most severe food crises in Earth's geological history. Long before the invention of white refined table sugar, candy factories, or carbonated soda cans, your ancient hominid ancestors lived in a harsh wilderness where pure sweetness was one of the rarest, most dangerous substances on the planet. For over 99% of human existence, there were no sugar refineries, no pastry shops, and no sweet drinks. Sweetness existed only in brief, unpredictable seasonal windows, hidden inside sour wild fruits, or guarded inside high cliffside beehives by thousands of venomous stinging insects. To understand why your brain lights up like a pinball machine at the mere sight of a sweet donut, we have to travel back 15 million years into the ancient, prehistoric jungle canopy. 15 million years ago, during the Middle Miocene epoch, the planet Earth began to undergo a massive, catastrophic climate shift. Lush, warm, tropical rainforests that had covered vast stretches of Europe, Asia, and Africa for millions of years began to shrink at an alarming rate. Global atmospheric temperatures plummeted, transforming dense jungle canopies into dry, open, highly seasonal temperate woodlands. For ancient tree-dwelling primates like Dryopithecus and Proconsul, this sudden environmental shift was an absolute existential catastrophe. In the old tropical rainforests, ripe fruits had been available almost every single day of the year. Ancient apes could swing lazily from branch to branch, eating juicy figs, sweet wild berries, and soft tropical leaves whenever they felt hungry. But in the new seasonal woodlands, fruit trees produced food only during a brief autumn window. When winter arrived, the trees dropped their leaves, fruits disappeared completely, and the forest turned into a frozen, barren wasteland for 6 long months. Over 80% of all ape species living across Europe and Asia went extinct during this prolonged Miocene cooling event. They simply starved to death when the seasonal fruit canopy vanished. However, a tiny group of ancestral hominids survived, not because they grew larger teeth, sharper claws, or thicker fur, but because of a microscopic genetic accident buried deep inside their cellular machinery. If you find evolutionary science fascinating, consider hitting the subscribe button to support our channel. Dr. Richard Johnson, a medical researcher and professor of nephrology at the University of Anschutz, proposed that around 15 million years ago, a critical genetic mutation likely spread rapidly through the surviving population of Miocene apes. In almost all mammals, an active enzyme called Uricase breaks down uric acid in the bloodstream. But during this severe Miocene famine, our ancestral hominids suffered a pseudogenization mutation that completely destroyed their functional uricase gene. At first glance, losing a functional enzyme sounds like a dangerous biological flaw. High levels of uric acid in modern humans are infamous for causing painful gout, kidney stones, and chronic joint inflammation. But in the starving forests of the Miocene epoch, this exact genetic defect turned out to be the ultimate evolutionary jackpot. When an ape with a uricase mutation managed to find a rare, semi-ripe wild fig, the fruit contained a natural simple sugar called fructose. In normal mammals, fructose is slowly converted into immediate energy. But in our mutated ancestors, the complete absence of the uricase enzyme meant that consuming fructose caused an immediate, massive spike in blood uric acid levels. And that uric acid spike acted as a master metabolic switch inside the liver.
Instead of burning the fructose right away for daily activity, the uric acid switch forced the ape's liver to rapidly convert every single molecule of fructose into stored body fat. At the exact same time, it induced a state of temporary insulin resistance, preserving precious blood glucose specifically for brain function, while accumulating a thick layer of protective abdominal fat. Apes carrying this uricase mutation could eat a small harvest of autumn figs and gain twice as much winter fat as non-mutated apes. When the long, freezing winter arrived, non-mutated apes starved to death, while mutated apes slowly burned their stored fructose fat and survived until the warm spring return. Geneticists refer to this ancient biological survival mechanism as the Thrifty gene hypothesis. Your body did not evolve to maintain a lean, low-fat physique in an environment of endless food abundance. Your body evolved to view every single molecule of sugar as a rare, life-saving fuel tank that must be converted into fat immediately before the upcoming winter famine arrives. As millions of years unfolded and early hominids eventually descended from the shrinking trees to walk upright on the African savanna, our ancestors encountered a major dietary challenge. Wild fruits on the savanna were small, fibrous, extremely sour, and highly seasonal. They contained only tiny amounts of fructose compared to modern cultivated apples, oranges, or bananas. Early humans needed an even more concentrated, energy-dense source of pure sugar to fuel their rapidly expanding, energy-hungry brains. Human brain tissue is one of the most metabolically expensive structures in the animal kingdom. While the adult human brain accounts for only 2% of total body weight, it consumes over 20% of the body's entire daily metabolic energy budget. Brain cells rely almost exclusively on glucose for fuel. In the unpredictable wilderness of the Pleistocene epoch, where hunting large game was dangerous and gathering wild roots yielded low calories, finding a dense source of fast-acting sugar was a matter of life and death. Paleoanthropologists studying early hominid dental wear patterns have confirmed that our ancestors spent vast amounts of time searching for high-energy plant foods long before their physical dental structures evolved to chew fibrous vegetation easily. This behavioral drive to seek out energy-dense carbohydrates accelerated our cognitive evolution and shaped early human foraging strategies. And that is when ancient humans discovered the most potent, most dangerous, and most prized substance in the entire prehistoric wilderness: wild honey. Wild honey is composed of roughly 40% fructose and 35% glucose, making it the most calorically dense natural food on Earth, offering over 3,000 calories per single kilogram. To a Paleolithic hunter-gatherer who spent exhausting days digging for tough, bitter roots or chasing lean wild antelopes, finding a wild beehive was like discovering a chest filled with pure gold. Archaeological discoveries prove that early humans developed an intense, dangerous obsession with harvesting honey thousands of years ago. In the Spider Cave of Valencia, Spain, archaeologists discovered a famous 8,000-year-old Mesolithic rock painting. The painting vividly depicts a brave, prehistoric human climbing a fragile, rickety ladder woven from wild vines, reaching high up a vertical canyon wall to extract honey from a wild hive, while a cloud of giant, angry bees swarms overhead. Even today, we can look at modern hunter-gatherer societies like the Hadza people of Tanzania to see how our ancient ancestors interacted with sweet foods. For the Hadza, honey is not a light dessert, a topping, or an occasional luxury item. During the peak honey season, wild honey accounts for up to 15 to 20% of all calories consumed by the entire tribe. The Hadza have developed an extraordinary, cooperative evolutionary relationship with a wild bird species known as the honey-guide bird. When a honey-guide bird spots a wild bee nest hidden deep inside a hollow baobab tree trunk, it flies directly toward a Hadza hunting camp, emitting a specific, persistent chirping call. Hadza foragers instantly recognize the bird's signal and follow it through the dense bush for miles. Once the humans reach the tree, they light bundles of green leaves to smoke out the bees, chop open the thick wooden trunk with stone axes, and harvest the rich golden honeycomb. In return,
The humans leave behind generous portions of beeswax and fat larvae for the bird to feast upon. Imagine it is you climbing those same 40 feet, bare hands gripping bark, bees landing on your neck one after another as you force yourself higher. Hadza men do exactly this, enduring dozens of agonizing stings across their bare shoulders and chest, just to retrieve a single handful of wild honeycomb. When field researchers ask them why they endure such severe pain for honey, their answer is always immediate and clear. Sweetness is the purest, most valuable substance in the world. Your tongue contains specialized sweet taste receptor proteins called TAS1R2 and TAS1R3. When even a tiny molecule of sugar binds to these receptors, they trigger an instantaneous nerve signal directly to the nucleus accumbens, the primary reward center of your brain. Your brain immediately floods your central nervous system with dopamine, creating an overwhelming feeling of intense pleasure and deep satisfaction. In the dangerous prehistoric wilderness, this powerful dopamine reward system served a critical evolutionary purpose. It taught your brain that sweet-tasting foods were safe, non-toxic, and packed with life-saving calories, while bitter-tasting foods were likely deadly botanical toxins. Share your thoughts in the comments below. If you lived in the Paleolithic wild, how far would you go for a taste of raw honey? For over 99% of human history, this biological survival system operated in flawless harmony with nature. Sugar was so rare and so difficult to obtain that humans could never consume enough of it to cause metabolic harm. A Paleolithic hunter might enjoy a massive wild honey feast once every few months, or feast on sweet autumn berries for 2 weeks, and then go months without tasting a single drop of sweetness. Everything changed around 8,000 years ago on the tropical island of New Guinea. Indigenous Papuan farmers began cultivating a tall, thick marsh grass with a sweet, juicy interior, wild sugarcane, known scientifically as Saccharum officinarum. Papuans would harvest the green stalks, peel away the tough outer rind, and chew the raw, fibrous pulp to extract the sweet sap. From New Guinea, sugarcane traveled along ancient sea trade routes into Southeast Asia and eventually arrived in India around 500 BCE. It was in ancient India, during the golden age of the imperial Gupta dynasty, that human civilization achieved a monumental, revolutionary technological breakthrough: the invention of sugar crystallization. Ancient Indian artisans discovered that by crushing sugarcane stalks in heavy wooden presses, collecting the sweet green liquid, and boiling it down slowly over open clay hearths, the water would evaporate, leaving behind hard, sparkling white crystals. They called these sweet granules sharkara, a Sanskrit word meaning fine gravel or sand. This ancient Indian word, sharkara, became the direct linguistic ancestor of the Persian shakar, the Arabic sukkar, the Latin saccharum, the French sucre, and the modern English word sugar. When solid sugar crystals first appeared in the ancient world, they were not eaten as everyday food. For more than 1,000 years, crystallized sugar remained one of the rarest, most expensive luxury status symbols on Earth. Persian emperors, Roman physicians, and Islamic caliphs treated sugar as a sacred, precious medicine. Medieval European kings purchased tiny vials of sugar from Venetian merchants at astronomical prices, using it to coat bitter medicinal herbs, or carving giant, solid sugar sculptures to display their immense wealth at royal banquets. During the Middle Ages in Europe, a single pound of refined sugar cost the equivalent of several months of a skilled laborer's wages. Wealthy aristocrats displayed sugar sculptures shaped like castles, lions, and crowns on their banquet tables, eating so much pure sugar that their teeth turned black, which bizarrely became a fashionable symbol of extreme wealth among European nobility. Ancient medical texts from Egypt, Greece, and China reveal that physicians prescribed small doses of honey and raw sugar juice to treat abdominal wounds, eye infections, and respiratory illnesses. Sugar was regarded not as a dietary staple, but as an exotic, miraculous pharmacological substance capable of restoring energy to dying soldiers. In the medieval European world, owning a small jar of white sugar was equivalent to owning a chest filled with gold coins. But this ancient luxury status contained a dark, catastrophic historical shift that would eventually transform human health forever. During the 16th and 17th centuries, European colonial empires established massive, brutal sugarcane plantations across the Caribbean, Brazil, and the American South. Millions of enslaved Africans were forced under unspeakable conditions to clear tropical forests, plant sugarcane crops, and operate boiling houses, their hands scarred by machete blades and their bodies burned by the same boiling syrup that would eventually sweeten a stranger's tea an ocean away. The massive influx of slave-produced sugar flooded European markets, turning sugar from a rare regal medicine into a cheap, abundant daily staple for the working class, at a human cost that rarely made it into the history books sold alongside the sugar itself. As the Industrial Revolution swept across Europe and North America during the 19th century, factories began mass-producing refined beet sugar and liquid syrups. Workers in urban factories, facing long 12-hour workdays, relied on sweet black tea and cheap jam on bread for quick, inexpensive energy bursts. By the late 20th century, industrial food processing introduced high-fructose corn syrup, refined white table sugar, and artificial sweeteners into nearly every packaged product found on grocery store shelves. Today, the average person living in many developed nations consumes over 70 pounds of added refined sugar every single year, an amount that would have shocked our ancestors. And here lies the ultimate, tragic evolutionary mismatch of modern human existence. Your body is still running the exact same biological software that kept Miocene apes alive 15 million years ago. Your liver still carries that ancient, unyielding Uricase gene mutation. When you drink a large sugary soda, eat a sweet pastry, or consume processed snacks loaded with high-fructose corn syrup, your body's ancient survival switch instantly flips to on. Your liver perceives the sudden flood of fructose and assumes that a harsh, freezing winter famine is about to strike the forest. It spikes your blood uric acid levels, shuts down your fat-burning metabolic pathways, and aggressively converts every excess calorie into visceral body fat stored around your vital organs. It induces insulin resistance to hoard blood glucose for a brain that is no longer in any danger of starving. Unlike glucose, which can be metabolized by almost every cell in the human body, fructose can only be processed by the liver. When high-fructose corn syrup floods the liver in massive quantities, the liver becomes overwhelmed. It synthesizes triglycerides at an alarming rate, leading directly to non-alcoholic fatty liver disease, systemic inflammation, chronic elevation of blood pressure, and type 2 diabetes. Biologists note that our modern agricultural systems have turned sweet taste into an omnipresent background noise. In the Paleolithic wilderness, sweet taste signaled a rare, life-saving jackpot once every few weeks. Today, sugar is hidden in bread, salad dressings, canned soups, cured meats, and savory sauces, keeping our ancient metabolic survival switch perpetually activated 24 hours a day, 7 days a week. Human civilization managed to engineer an environment of boundless, instant gratification, but our underlying physiology remains firmly anchored in the resource-scarce Miocene epoch. I find it almost unbearably strange that the same craving which once drove a starving ape up a tree and a stolen human up a bee-infested cliff now just makes you reach for a vending machine without a second thought. We are ancient foragers stranded in a modern candy store. The next time you feel a powerful, almost uncontrollable urge to reach for a sweet treat late at night, try not to judge your character too harshly. You are not weak, lazy, or lacking in moral discipline. You are simply experiencing the deep biological echo of an ancient ape who survived a freezing Miocene winter 15 million years ago by clinging to a tree branch and eating wild autumn figs. Our modern battle with sugar is not a failure of individual human willpower, but a profound structural conflict between our deep evolutionary past and our hyper-industrialized present. We created a modern world of unlimited sweetness using a body that was engineered for infinite scarcity. Understanding where our deepest biological cravings come from is the first essential step toward reclaiming control over our health, our diets, and our human future. Thank you for watching Mindplicit Survival. How do you manage your own relationship with sugar in today's sweet-filled world? Share your thoughts and experiences in the comments below, and do not forget to like, subscribe, and share this video with anyone who appreciates the hidden evolutionary history of human life. Modern evolutionary anthropologists studying early hominid foraging strategies have noted that our ancestors' obsession with sugar was not limited to fruits and honey. Prehistoric foragers actively sought out sweet plant secretions, wild nectar, and sugar-rich tree saps long before agricultural techniques were conceived. Every encounter with a sweet natural food item served as an immediate metabolic lifeline, reinforcing the neural pathways that associated sweet flavor profiles with immediate physical relief from chronic hunger. Evolutionary biologists emphasize that our modern metabolic machinery is not malfunctioning, but rather functioning with ruthless efficiency in an environment for which it was never designed. Every molecular pathway, every taste bud, and every neural signal was sculpted by millions of years of recurring famine.